It's a pleasure to be here, and thank you for inviting me to give this talk. It's a real pleasure. And I think the first point I should like to make is, I've called the talk The Fitness of Nature for Mankind. And I'll state brutally my view. I think the scientific evidence today suggests very strongly that a divine agent ordered the way the world is, ordered the structure of the world for our existence. That's a strong statement. This means essentially I'm defending that view here in this lecture. And of course, it's basically the same as the medieval anthropocentric worldview that was held before the scientific revolution. It was the common view of Jewish, Muslim, and Christian scholars that man was the center of the world, that the whole world works together in the service of man. And another author describes the medieval scholars as holding the central place in the world which God had made belongs to man. And their anthropocentric views were quite extraordinary. They saw a deep correspondence between human biology and the nature of the cosmos. Each part of the body corresponded to a part of the universe. The head to the skies, the breath to the air, bones corresponded to the rocks, the veins to the branches of the trees. So this was an extraordinary view of the world. Everything worked to the service of man. A divine agent had planned the world, the universe, for man. It's an extraordinary claim, and in the context of current knowledge of the size of the universe and what we now know about the universe, it's perhaps the most extraordinary claim. Well, perhaps the resurrection of Jesus might be sort of, up there as well. But this is an extraordinary claim that the cosmos was designed for beings like ourselves. Now, we all know what happened after the medieval era. At the birth of science, with the work of Copernicus and the early anatomists, as science began to reveal facts about the world, there simply was no evidence of any fine-tuning or place of man in nature. So this was a colossal cosmic shock to Western civilization. Okay, you can contrast the fact that there's no connection between, here's Andreas Vesalius in Padua, he's dissecting the human body. There's no connection between the strange sinews in the arm and the Copernican cosmos. There's no connection. So this was the great shock, and the shock got worse because then there was the telescope, then there was the microscope, there was Harvey's circulation of the blood, there was the Newtonian synthesis. But none of this put man back into the center of the cosmos. So that in fact, for the first 3 or 4 centuries of science, until in fact the early and mid-19th century, there was very little evidence that we had any special place in nature or there was any divine agent behind reality organizing things for us. However, the first signs that there might be some fine-tuning for life as it exists on Earth came with the development of organic chemistry in the 19th century. There was the discovery of the unique fitness of the carbon atom, and this provided the first scientific evidence that nature might be fine-tuned for life as it exists on Earth. Not man-mind, but life, but carbon-based life. Alfred Russel Wallace defended the uniqueness of carbon chemistry for life in his The World of Life. We see, therefore, he said, that carbon is perhaps the most unique in its physical and chemical properties of the whole series of elements. And so far as the evidence points, it seems to exist for the one purpose of rendering the development of organized chemical life a possibility. And that was Wallace's view in the early 20th century. And during the 20th century, nearly all researchers eventually came to accept the same view that Wallace had expressed there, that indeed, in fact, nature seems uniquely fine-tuned for carbon-based life. And I've just mentioned some of the authors there: George Wald, Michael Gross, Kevin Paxco, Peter Atkins, Norman Pace, Lynn Rothschilds, and even Carl Sagan considered himself a carbon chauvinist. So basically, what this means is that from the early to mid-19th century to the latter part of the 20th century, it became accepted by nearly everybody that you could say that the universe had been fine-tuned for carbon-based life. Or you could put it into design terminology, that an intelligent agent had ordered nature for carbon-based life. At least the evidence was consistent with this. And incidentally, I should perhaps warn you that, in fact, I won't be able to prove my belief that a divine agent ordered the world for life in this talk, but I'm going to present evidence that is entirely consistent with that position, and I think strongly suggestive. So what of man? Might there be a special fitness in nature for our type of being, not just canonical carbon-based life? Might the universe be anthropocentric, as Roger Bacon believed? Well, we'll see. The method I'm going to use to try and convince you that it is indeed anthropocentric, that it was really fine-tuned for us, in a second. I like the famous quote of Thomas Huxley when he said, "The question of questions for mankind, the problem which underlies all others and is more deeply interesting than any other, is the ascertainment of the place which man occupies in nature and of his relationship to the universe of things." And I disagree with much of Thomas Huxley's views, but in this case, I think I agree with what he says. We are terrestrial, warm-blooded, aerobic, air-breathing organisms. And that means we belong to a special class of carbon-based life. And it obviously raises the possibility, is it the case that there seems to be fine-tuning in nature for this category of being, terrestrial, warm-blooded, aerobic, air-breathing organisms? And in addition, we are also capable of fire-making, and through fire-making, we're able to develop metallurgy and develop an advanced technology. So we can ask another question. Is there any special fitness in nature for making fire? So overall, is there any special fitness in nature for beings like ourselves that have our physiological design and are capable of making a fire? Fire making is extremely important because through fire came metallurgy, the Industrial Revolution, and that's why you're sitting there now. Without man's ability to make fire and learn metallurgy and chemistry, there would have been no advance to the 21st century. Just a note, I keep using the word fitness. What I'm talking about is the fitness of the environmental preconditions which are necessary for the actualization of key innovations which underlie our biology. Now, many biologists talk about, for instance, the fitness of the lungs, the fitness of the circulatory system, the fitness of the eye as functional entities, right? But I'm talking about the environmental preconditions which enabled their actualization. I'm not talking about I will not be talking in this talk about any specific organ in the human body, wonderful though they are, and they exhibit enormous elements of design, but I'm talking about the conditions that allowed their actualization, conditions which are in the very ground of being of the cosmos itself. First of all, we are a terrestrial being, and terrestrial life needs water. And how do we get water? Well, this story I'm going to tell now is, I think, for me, absolutely amazing and stunning. We get water via what is called the water cycle, and it's how water delivers itself to the land. This cycle depends on the unique capacity of water to exist in three material states in ambient conditions on Earth. In other words, water can be solid, it can be ice, it can be water, it can be a vapor. And so water can evaporate from the seas, it can go up into the upper atmosphere, it turns into rain and comes down onto the land. Now think how clever this is. Already we're starting to touch something really remarkable. Terrestrial life doesn't require a complex mechanism to get the precious water to the land. It depends on the properties of water itself, the very matrix of life. This is beautiful teleology now. So water has a unique property, and it's uniquely fit for the cell and for life, and it delivers itself to the land to make terrestrial life possible. And that's how you're sitting here as well. But in addition, the teleology starts to deepen. In addition, terrestrial life needs essential elements. The basic elements of oxygen, carbon, hydrogen, and nitrogen can be extracted from the atmosphere and from water itself. But we need a host of other elements. Where do we get them? How are we going to get the additional elements? The water, by an incredibly unique property, delivers itself to the land. Well, you know what? As it flows back to the sea, it takes those elements out of the rocks and delivers them to the terrestrial hydrosphere. So there's just wheels and wheels of design coming out here all the time. And it's designed for us. It's designed for a particular category of living things, terrestrial beings on the land. So the essential minerals are delivered to the land by the erosion and weathering of the rocks by water. Water's erosion and weathering of the rocks provides the essential minerals for life on the land. Now, the teleology deepens further, because this substance, water, not only delivers itself to the land and takes stuff out of the rocks, it is perfect in so many ways for its erosional function, its weathering function. It's an excellent solvent. It has high surface tension, and this allows it to enter the cracks in the rocks, and it expands on freezing uniquely. And so it breaks the rocks up. And it reacts with carbon dioxide in the air, and it forms a weak acid, which helps in the erosion and weathering of the rocks. On top of that, it has a low viscosity, which means it has high mobility. So it moves over the waterfalls and the rocks, giving itself force, carrying small particles of rock, and chips away. It's high, so its low viscosity gives it mobility. And the low viscosity of ice also ends in erosion. Ice is a crystalline solid, but it's got almost one of the lowest viscosities of any crystalline solid, so it flows back to the sea. Thank goodness it does, because if it didn't do that, all the water on the Earth would be locked in great polar masses in the colder parts of the world. So water delivers itself to the land. It has exactly the properties you want as it returns to the sea to leach out the minerals and essential elements from the rocks. Now there's one other little catch as well, which is even, I think, more amazing. Plants need water-retaining soils. Where do they get the water-retaining soils from? From the erosion of rocks by water. And how is water held in the sands and soils? By surface tension, the property of water. And so if erosion had just resulted in some pebbles, then the water would just rush through the pebbles, right? And it would never be retained. We wouldn't have plants on the land. We certainly wouldn't have big trees. But the erosional process goes right down to sands and silts, which have just the properties you want to retain water, to have plants on the land. And who needs plants? Animals like us. Now, I would say that already what I've mentioned now suggests there is a fitness in nature for terrestrial life of an absolutely incredible kind. Putting together all these diverse material properties of rocks, of water, and such like, I would say this presents one of the most powerful evidences for design in nature that I'm aware of. And it's the very ground of being. It's eternal and it's a universal. Our terrestrial lifestyle is only possible because of what would seem to be a vastly improbable ensemble of material properties. The impression that an intelligent agent orders things specifically for terrestrial being is irresistible. And look at the result of this process. The giving of life is entwined with the giving of beauty. This is the Torres del Paine National Park in southern South America. So we are also warm-blooded organisms, and we maintain our temperature at a certain level. That's homeothermy. Homeothermy allows organisms like us to function at the same temperature regardless of environmental temperatures. Warm-blooded homeothermy gives faster nerve conduction, reflexes, faster muscle contraction, temporal resolution of the eye increased, and so forth. It turns out that water again, it seems to be always revolving around water, but it turns out that water has a very high specific heat. If you want to maintain your body temperature at a constant level, that's an enormously convenient property, because it means that, in fact, the temperature of the body remains the same even if you add heat to it or take heat away. And I think if it wasn't for the high specific heat of water, you wouldn't have warm-blooded homeotherms. I think that would be impossible. Lawrence Henderson commented, an adult human weighing 75 kilograms when at rest produces daily about 2,400 great calories, which is an amount of heat sufficient to raise the temperature of his body more than 32 centigrade. But if the heat capacity of his body corresponded to that of most substances, the same quantity of heat would be sufficient to raise his body temperature between 100 and 150 degrees. Hence, the fitness of the high specific heat of water for homeotherms. But there's another point. Water has the highest latent heat of evaporation of any known molecular substance. And this allows warm-blooded organisms to excrete excess heat at temperatures higher than body temperature. Now, think of this. How many people on Earth live when the temperature goes over 37 degrees for several hours? You're talking billions. If I had a magic wand and I could abolish that particular property of water, Olympic athletes will be dead in a few hours because you can't lose heat. Henderson comments on this again. You see, no other liquid could, during the evaporation of a given quantity of material, bind so much heat. No other vapor could yield so much heat on condensation. At body temperature or above, there can be no loss of heat at all by conduction and radiation, and the whole burden is therefore thrown on evaporation. If you look at a map of the world, just to remind you, vast areas are over 40 degrees for several hours. So our existence as warm-blooded organisms maintaining a high body temperature with active metabolisms is absolutely dependent on the thermal properties of water. Humans would not exist, mammals would not exist, birds would not exist without this property. It's a deep precondition built into nature, I would say, from the very beginning, with beings like ourselves in mind. These parameters were at the moment of the Big Bang. And the properties of water presage only one thing: terrestrial life on a planet like the Earth with this sort of thing. That's the only common sense, reasonable deduction you can make. So terrestrial warm-blooded homeothermy depends on the unique fitness of the thermal properties of water. And again, the impression, as I've already said, that an intelligent design ordered things for that seems to me to be quite irresistible. Okay, the next thing is we are aerobic. That means we use oxygen to get energy. Once again, that's a small category of all life forms. There's a small category of life forms which are terrestrial, small that are warm-blooded, and a small category which are, in fact, aerobic. So let's think about aerobic metabolism. All complex life on Earth is aerobic, utilizing oxidation as a means of energy generation. But simple life forms in the subsurface, in the rocks, and all sorts of other places are anaerobic. They don't use oxygen. So the use of oxygen is something that, in fact, is one of the unique features of our biology. You won't believe it, but a 70-kilogram adult human uses 14.5 liters of oxygen per hour. That's 250 mils a minute. As you're sitting there now, you are using 250 mils of pure oxygen every minute. That figure really blows my mind. I mean, 250 mils of this pure element you need to keep your energy going, to make ATP, to keep the cells, to keep the body alive. 250 mils. And why do we need the oxygen? Because oxidations provide very great quantities of energy. The reaction which powers the world, and you can see the power of oxidations in forest fires, because a forest fire is basically just a rapid oxidation of reduced carbon compounds. In the body, the process occurs very much more slowly, but in a forest fire, it's uncontrolled. So, how do we get oxygen? Okay, well, we get oxygen through the process of photosynthesis. In essence, this process involves the use of light energy to draw electrons and protons from water, oxidizing the water to oxygen, which is released into the atmosphere and reducing carbon dioxide to sugars and various reduced carbon compounds. And that's the overall basic formula. So let's consider the fitness in nature, the preconditions in nature for photosynthesis. And this is every bit as extraordinary as the story of terrestrial life. Just to remind you about the electromagnetic spectrum. This is a spectrum of radiations which range from very energetic and very small wavelengths, that is, the wavelength is from crest to crest, to very low energy radiations in the radio wave area, which are very, very long. So in fact, we have this vast, vast spectrum of radiations. And within that spectrum, of course, is the visual band. Everybody's aware, I think, of gamma rays, X-rays, UV, microwaves, and radio waves, and so forth. These are all wavelengths along this vast spectrum. The visual spectrum is a small spectrum in the middle of this vast range of radiations. And it is this visual tiny line which has just the right energy for photosynthesis and for photobiology. Now, what would you imagine if you were arranging the world for life? What would you imagine the radiation output of the sun would be? The sun is a pretty well common, ordinary sort of star. The radiation of the sun comes out in the most of it comes out in the visual band, in that tiny band. And the rest of the radiation of the sun is in the infrared, the heat band, which I'll talk about in a minute. So amazingly, what this, of course, now means is that the output of the sun and most stars, the vast majority of stars in the cosmos, is concentrated in exactly that band you need. Now, this is two features. First of all, you've got the band that's useful for biology, useful for photochemistry, and the sun puts out just that band, most of its energy in that band. So the cosmos is, in a way, flooded with the light of life. So what would you think if you were playing the demiurge, Plato's demiurge? Well, how would you fix the atmosphere? Well, you'd like the atmosphere to let through that light. And that is exactly what we find. When you look at the absorption of electromagnetic radiation in the atmosphere, you'll find that it lets the visual light right through to the ground, which is exactly where you want it. It blocks out the radiation on the more energetic radiations, UV, X-ray, and gamma ray, and it lets which is just adjacent to it, but it lets the visual light right through to the ground. So this tiny band comes out, which is one tiny fraction of the electromagnetic spectrum, which is useful. The sun puts it out, and the atmosphere lets it right through. I mean, that's three staggering coincidences in nature which have to be true for our being. And what about water? Well, of course, water, being the matrix of life, it also has to let through the light. And this is just a graph showing that it does. Liquid water has the same visual window as the atmosphere. Obviously, it has to, because, in fact, it's the matrix of life. Something that's never really mentioned, though, about these remarkable coincidences is that when you think about it, what are the gases in the atmosphere which are letting through the right light and blocking out all the other radiations? Well, one of them is CO2, one of them is water vapor, and one of them is oxygen itself. So that the actual compounds which are involved in photosynthesis as chemical compounds have the right physical attributes to let through the light. It's as if they're colluding together to incorporate themselves in organic matter in photosynthesis. I find that. And these gases are not just peripheral players, they are the major reactants. In other words, it is the three major reactants, CO2, H2O, and O2, which ensure by their collective absorption properties in the atmosphere the availability of the vital light energy necessary to drive the reaction to completion. It is as if these three gases were colluding intelligently to promote their incorporation into the substance of living matter. Absolutely beautiful. This is transcendent engineering on a staggering scale. So I can summarize what we have here as a series of staggeringly, ludicrously improbable coincidences. One tiny band of utility for living processes. One tiny band, the same band given out by the sun. The same band allowed through the atmosphere. The same band let through water. So here we have four coincidences of a staggering kind, and that's why you're sitting here. Take away any one of those things from the ground of being, and you don't have any existence. You're finished. So these are the preconditions. Now I know that in fact the origin of photosynthesis is a big evolutionary problem, and it's very interesting to work out how it was designed or how it happened. But unless these conditions held from the moment of creation, there'd never have been photosynthesis. And they've never, however it actually did occur. And even God, creating the first sort of chloroplast, had to have these conditions right. I love this quote from the 15th edition of the Encyclopedia Britannica. Considering the importance of visual sunlight for all aspects of terrestrial life, one cannot help being awed by the dramatically narrow window in the atmospheric absorption and in the absorption spectrum of water. One should be awed at these facts, actually. When we're talking about sunlight, I just want to make another point about sunlight, which is absolutely intriguing. I'm not sort of following exactly the same track, because in fact all life on Earth needs to be warmed, certainly all life on the surface of the Earth. When you notice, when you look at this, of course, the visual light comes straight down to the ground. That's just what you want. But you don't want the infrared radiation. You don't want heat to just come to the ground and then radiate it out. What you need to retain heat is you need some absorption of the infrared in the atmosphere. So exactly what you see, the light, which promotes photosynthesis, gets right round to the ground, and there are absorption bands in the IR area which absorb the heat. If you magically just moved it across a bit into the visual region, there'd be no photosynthesis. So the pattern, the way that the atmosphere lets visual light through and the way it handles infrared heat irradiation is exactly what you want for life on Earth. I've already quoted Carl Sagan once, and I'm not going to quote him again because I do love this quote. I do it in many of my talks, and it does take a few minutes, but I'll just read it. Think of the sun's heat on your upturned face on a cloudless summer's day. Think how dangerous it is to gaze at the sun directly. And then he says, what would we feel on its seething self-luminous surface, or immersed in its heart of nuclear fire? The sun warms us and feeds us, and permits us to see. It fecunded the earth. It is powerful beyond human experience. Birds greet the sunrise with an audible ecstasy. Even some one-celled organisms know to swim to the light, and that's true. Our ancestors worshipped the sun, and they were far from foolish. And I hope we're all worshipping the sun again. Or at least the divine agent who ordered the structure of the things behind it. Okay, now, we are terrestrial organisms. We need oxygen because we have a very high metabolic rate. But we're going to have to take our oxygen from the air as terrestrial organisms. Now here is now a relatively small category of organisms that we belong to. That is air-breathing, oxygen-utilizing organisms. Just by the way of passing, air-breathing is more efficient than water-breathing. So it's much more difficult to extract oxygen from water as it is from air. And that's why, in fact, organisms like a hummingbird that have a very, very high metabolic rate are inevitably air-breathing. They're getting their oxygen supply directly from an atmosphere. Fish and other aquatic organisms have lower metabolic rates, and it's impossible for them to raise them high because the water is not enough oxygen in the water to do it. So another element of fitness for terrestrial air-breathing things is that it's much better on the land. You know, if you want to build a rocket to the moon, or you want to hum like a hummingbird or buzz like a bee, you better come out the water because it's much better on the land. And we've already seen that the divine agent has prepared the fitness for life on the land, and now we're going to see other aspects of this unfolding. So basically, all advanced organisms on Earth breathe air. They take their oxygen directly from an atmosphere. But this raises a nightmare, which was raised. The question is that oxygen is such a reactive substance. How come we don't all spontaneously combust? I mean, you know, it's one of the most paradoxical things that we're living in an atmosphere which is so dangerous. That it's because of the reactivity of oxygen. And Arthur C. Clarke, he asked the question, there is one mystery I'm asked about more, the spontaneous human combustion. And Nick Lane is a biochemist in London. He raised the same question in his book, Oxygen. The massive amount of heat released, this is when oxygen reacts with carbon compounds, like in a forest fire, suggests that burning should proceed almost spontaneously. So here we have, perhaps is this a hitch of the universe? Well, not really, because for some strange reason, as you experience when you make a campfire, when you go to start a campfire, it's difficult to get it going. Once they go, they start to burn. And the reason is that, in fact, what's happening in the campfire is as soon as the campfire is started, the heat of the fire activates the oxygen in the air, and it becomes self-sustaining. You have to add a little bit of energy to get the fire going. The reason for this is that there's a unique electronic characteristics of the oxygen atom. The fact that living things do not burst spontaneously into flame betrays an odd reluctance on the part of oxygen to react. This reluctance is because of certain unique electronic characteristics of the oxygen atom, technically referred to as spin restricted. Without the barrier, no reduced carbon compounds could persist for any length of time on the Earth's surface. There would be no photosynthesis, no plants, no forests, no humans. We could never have accumulated oxygen in the atmosphere or crawled out of the oceans. Forgive me, he is an evolutionist, but you know, so forth. So therefore, the amazing thing, this one atom, which creates so much energy and is so useful for our biology and physiology, has a specific, unique feature which makes it very difficult to react vigorously and in ambient temperatures. In other words, its activity is attenuated by spin restriction. Amazing. Again, on that fact is why you're sitting there. So I've mentioned a lot of facts why you're sitting there now. This is an absolute precondition for oxidative metabolism in biological systems like ourselves. That at ambient temperatures, the activity of oxygen is massively attenuated. But there's another problem as well. Living in this atmosphere, once a fire starts, it can spread uncontrollably, because I've said, you know, once the campfire is going, it starts to spread. And there's something else in the atmosphere, it's another factor as well, and that is nitrogen. Nitrogen acts as a fire retardant, retarding the rate of fire spreading. And basically, you need about a mix of 20% oxygen and 80% nitrogen to have a mixture which, in fact, will allow fire to occur and spread slowly, but never uncontrollably. If nitrogen wasn't in the atmosphere, despite the spin restriction, if a fire starts in Seattle, it'll spread all the way to Florida, right across America. You never stop it. It'll be absolutely uncontrollable. And the quenching effect of nitrogen is that nitrogen has a high specific heat. As the heat of the fire gets going, the nitrogen in the air keeps absorbing the heat. So it stops the activation of oxygen going too fast, and so it makes fire controllable. These are all factors for you and me in our form of life, our form of physiology. You might say, well, then that's funny. If oxygen's spin restricted and its activity is attenuated in ambient temperatures, how do living things use it? Well, without going into any specific details about this, the reason why we can manipulate, handle, and store oxygen in the body is because of the transitional metal atoms, like iron in hemoglobin, like iron and copper, and some of the metallo enzymes which handle oxidations in the body. So I'll just mention this in passing. I won't go into this in any more detail, but without the transitional metal atoms having exactly the properties they do, we couldn't handle oxygen. Now the requirements for handling oxygen are starting to build one after the other. There are additional elements of fitness for air breathing. The fact that oxygen and carbon dioxide are both gases and both soluble in water. The viscosity of air is very low, so the work of breathing is not too constraining. You can breathe in and out. You're doing this now. And at an atmospheric pressure of 760 milligrams of mercury, the density of air is quite low. These are additional elements of fitness. The fitness of the gaseous nature of CO2 is extraordinary. First of all, as Henderson points out, in the course of a day, a man of average size produces as a result of his active metabolism nearly 2 pounds of carbon dioxide. All this must be rapidly removed from the body. It is difficult to imagine by what elaborate chemical and physical devices the body could rid itself of such enormous quantities of material were it not for the fact that in the lungs it can escape into the air, which is charged with little of the gas. Were carbon dioxide not gaseous, its excretion would be of the greatest of physiological tasks. Were it not freely soluble, a host of the most universal physiological processes would be impossible. Here again we see that nature solves her own problems from the intrinsic properties of the constituents of the body. It's quite amazing. Just as, in fact, water solves the problem of the water wheel with its own spontaneous characteristics, actually. So here we get rid of the end product of oxidative metabolism by the very essential nature of that end product itself. Again, examples of what one has to say are transcendent engineering. Nature is also fit for the circulatory system because you have to get the oxygen from the lungs to the tissues, and you need a circulatory system just as you need a circulatory system to take heat from the body core to the periphery for excretion. And it so happens the diffusion rate of small molecules is extremely quick over short distances, which makes the circulatory system possible. At the same time, the viscosity of water is very low, which means you can force it through small tubes. So these are two physical properties in nature which make the circulatory system possible. On top of that, water has another number of ideal properties to form the medium of the circulatory system. It's a fluid, so it's incompressible. It has a low density and low weight. It's an excellent solvent. The relatively low viscous means you can put it through the capillaries, as I've just mentioned. All these are properties of water which make water an ideal substance for the circulatory system. So water is not just ideal for the great water wheel, the great geophysical water wheel, which gives water to the land. It's also absolutely ideal for the formation of the circulatory system. So a host of diverse elements of fitness in nature make possible air-breathing aerobic life. And let's talk quickly now at the end of this talk about the unique fitness of the utilization of fire and the development of metallurgy by man. In this talk, we've been talking about human physiology, and many features of our physiology as terrestrial beings, as aerobic beings, as air-breathing beings that we share with other organisms. But there's one thing we can do which no other organism can do, and that is we can make a fire. To make a fire, you need to have intelligence, you need to have a manipulative organ like the hand, and you need to be a certain size. This is an incredible story. So that the only being that ever existed on this planet that could make a fire is mankind. We are anatomically equipped to make a fire. Luckily for us, and this astonishing ability to make a fire led to metallurgy, the Industrial Revolution, to electricity, and the 21st century. They are the steps. If anybody disagrees with me, I would say that these are the steps which any intelligent being on any planet in the universe would have to take. I think there's no way of getting to metallurgy without fire making and so forth. Okay, so these are the steps we took. So we were equipped by our anatomy for making these steps. And what a story! Controlled fire making revealed a great chain of fitness in nature, leading from the Stone Age to the 21st century, from a Stone Age to a curiosity. Fascinating thing. Okay, so we can make a fire, but the conditions in which you make fire have to be very, very, very stringent, only very exacting conditions you can make a fire. The current atmosphere on Earth is unique in supporting both aerobic metabolism, that's our metabolism, in other words, it supports beings drawing oxygen from the atmosphere, and it also allows controlled fire making. And you might say, well, that's our atmosphere. But it's not the only atmosphere that can exist. There are many atmospheres, many different atmospheres in which aerobic life would thrive, but you could never make a fire. And there are other atmospheres which support fire, but not respiration. And one of them is at the Everest Base Camp. As anybody who's been there will know, if you can light your primus, as Edmund Hillary did on the South Col when he was making the first ascent of Everest, but it's difficult to breathe. If you go much higher, you can still make a fire. You can look, when you're on the Everest Base Camp, you look up, there's a jumbo jet going overhead, burning fuels. It's oxidizing fuels. It's way above your head, but you can't breathe up there, right? Well, surprisingly, there's a vast number of other atmospheres in which we could thrive, but we could never make a fire. And all mammalian life and all birds could also thrive, but you could never make a fire. But there's one unique atmosphere, and it depends on a huge number of conditions. Oxygen's relative unreactivity, which we've mentioned, that heat activates oxygen, that the uptake of oxygen in the lungs is unaffected by the presence of nitrogen in the air, that the partial pressure of oxygen in the atmosphere today is sufficient to support our oxygen needs, that the specific heat of nitrogen is close to what it is, the fact that nitrogen is stable in the presence of oxygen. By the way, this is just a short section of the list, right? So in other words, to have an atmosphere in which we can thrive and make a fire, there's only really one unique atmosphere in which you can do that, and that's the atmosphere on the Earth at present, and it's one of millions of different atmospheres. And that atmosphere is only fit for us, because no other organisms are habitually going to make fires or develop metallurgy. So this is, you might say, well, that's just, Mike, that's just a huge coincidence, okay? That's just a big coincidence. Well, it's not so much of a coincidence, because you next find that, in fact, wood or charcoal fires provide sufficient heat in a kilt to smelt metals from their ores. In other words, basically this atmosphere, which allowed us to have fire and the terrestrial, the making of sands and soils I mentioned before, which allows the growth of trees, all these factors together allowed us Homo sapiens to make fires and advance to metallurgy. And then there's the relative availability of the ores in the earth, rocks enriched in particular metal atoms. So in the fire-making story and in the move to metallurgy, nature is uniquely fit for beings of our biology to go from the Stone Age to the 21st century. And when you put this fact in conjunction with the other facts I've mentioned about the uniqueness of nature for our physiology and biological and basic biology, I think you have to conclude, the only conclusion you can make, the only sensible and rational inference from these facts is that an intelligent agent designed the world for beings like ourselves. This is my belief, and this is a conclusion which the alternative conclusion is it's just a huge fluke. Everything's just a huge fluke. This is completely crazy. You have transcendent engineering for life, you have fantastic fine-tuning of one or two vast numbers of different factors in nature, and you say just a fluke. Not only that, metals themselves are uniquely fit for tool making, and some metals are magnetic, others are electrical conductors. You have dynamos, you have electric technology, and then the rare earth metals have unique properties with many different applications. And the fitness of the rare earth metals fascinates me, because while the fitness of the atmosphere was fit for fire making and metallurgy, and wood fires gave you enough heat to smelt those metals, what's extraordinary is in the 21st century, we've found that rare earth metals are uniquely fit for all sorts of specific technological applications, which really rounds everything off. Because it means that, in fact, the suggestion that fire making was just a fluke, not a fluke, because it drew us to a conclusion in which we could use the rare earth metals. And I think that's something which is really quite staggering. So we engaged in this great adventure to understand the universe because nature lent a hand, because the ground of being was already prepared for these major steps. The existence of terrestrial life, the existence of warm-blooded organisms, organisms with a high metabolic rate, organisms using oxygen, the existence of an atmosphere which allowed fire making, and the unique path towards the 21st century. There are many elements of fitness in nature for beings of our physiological design. Fitness for the generation of oxygen by photosynthesis, fitness for terrestrial air-breathing organisms, fitness for high acuity vision, something which I haven't mentioned but which is in my book, Children of Light. But in addition, nature is also uniquely fit for fire making by beings of our biological design and for the development of metallurgy and the subsequent advance to a technological civilization. So therefore, I'm going to agree with Roger Bacon in the 1300s and the medieval scholars. They assert that the cosmos was designed by an intelligent agency for human being. And I think I've tried to show you here that, in fact, there are many facts consistent with that view. That the cosmos, as revealed by modern science, conveys the irresistible impression of having been designed by an intelligent agent for the benefit of mankind. Thus, the medieval scholars were right. In the cognition of nature, in all her depths, man finds himself. That's a beautiful phrase. Just to repeat Roger Bacon, the whole world works together in the service of man. A final thought is this. Is this the only Earth in the universe with intelligent life on it? Now, when I was coming here on the plane, I read the March issue of the National Geographic about exoplanets, okay? And I'm pretty sure the author or authors of that article wouldn't have agreed with almost anything I've said here today. But nonetheless, the search for another planet like the Earth is proving very, very hard. You know, it's now very strange. 5 years ago, had you asked me, are there clones of the Earth out there? I probably would have said yes, rare, but they will be out there. Now I'd have to say, it looks as if, and this I think is absolutely sensational, it looks as if this Earth is exceedingly rare. Now, if you want to find out just how rare it is, look at the 3rd episode of a BBC series produced this year called The Planets. And it's about Jupiter, the Godfather. On this program, what he describes is the dynamic history of our solar system, okay? Jupiter is spiraling into the sun, and it sucks out the hydrogen and helium and volatiles from the inner planet area, right? But then Saturn stops it going the whole way. If it had kept on sucking the stuff from the inner solar system, there wouldn't have been any rocky planets in the solar system. But Saturn had just the right structure to draw Jupiter out again and leave the rocky planets as they are. You look up, it's amazing. And if you look at Taylor's book here about planetary crusts, I'm just reading the end of it. He says, in the difficulty of producing clones of our present-day solar system makes its duplication, and this is this is from the great classic texts on crust, as unlikely as finding an elephant on Mars. Now, I think finding an elephant on Mars is pretty unlikely. You know? So I think we might even be able to conclude that the universe was not just designed for beings like us. It was designed for our species on this planet. I think that is now a thesis one can support. And that is the medieval synthesis. That's what was believed before the birth of science. And I'll tell you what I think. I think the destiny of science, and if you look at the fact we were fire making, we made technology, and we advanced the 21st century, that was built in. And the purpose of that great saga was that we would have knowledge of the world. And in the last 4 centuries, we've used that knowledge to find out how unique we really are. And so it's a great supreme irony in history that the medieval view of the world, which was overthrown by the first discoveries of science, is finally recovering. The Reconquista is occurring. Science is revealing that, in fact, man was indeed ordained into the nature of things and the very ground of being from the very beginning of time.